Well, our hope was uh, I've been with Chris Cullen's help. We've
Yeah.
been able to get a program to run on the nonstop that will talk to AWS.
Okay, I see. So
So
you'll be able to run everything on the nonstop
that
theoretically.
was, yeah, that was pretty much the intent. Now, whether we can accomplish that or not is another, because otherwise we then have to have a Windows machine configured large enough to handle. I guess we could just abandon the traffic when it comes across, but
Yeah, exactly. You would just basically you would save it into locally on the system, and then you'd basically consume it with a user exit that would also apply it into the AWS.
right, and then
All right,
and
yeah,
then delete it.
yeah, yeah. Either way is fine. It's just it'll be different. The user exit code will be different on the nonstop than it would be on the Windows side.
Right, a
Um,
DLL
but
versus bound in code. Yeah, I understand.
and the code itself, it's there's different calls and different way of doing things on the nonstop as opposed to the Windows side.
Well, is there a
But yeah, I mean,
preference one way or the other?
no, it's really up to you. However you want the architecture set up. Um, as far as like whether user exit on one side or the other is more efficient, I don't think that's an issue. I guess one thing to keep in mind is that let's see, if you have the user exit on the Windows side with a doc TRS setup where you have events being replicated into a doc file on Windows, and then you're reading the events out of that doc file and applying them to AWS, you have the ability to control it so that only committed events are processed by the user exit. Um, if you do it all on the nonstop side, I believe you will apply both committed or you'll apply uncommitted events as they are received by Shadowbase. But then it will also, like, if the transaction gets rolled back, it'll process the abort event or the undo events to make sure that it's consistent in the end.
Ah,
Um,
okay, so that could be an
that's
interesting
something.
challenge. Yeah,
Yeah,
okay.
right. That's something to keep in mind. Um, let me just think if there's. That's probably the biggest difference between just how data is processed on the nonstop versus
Right, right.
on by a TRS. And yeah, and the if you do put the user X on the TRS on the Windows side, um, the both committed and aborted events will still get replicated from the consumer out to the dock on the Windows side, but the TRS it'll basically ignore anything. It'll only apply committed events.
Okay,
So
you've used two terms I'm not familiar with, doc and TRS.
yeah, that's the setup on the Windows side. You replicate events into a doc, which is a database of change
Ah, okay.
on the Windows system itself, and so it's a bunch of flat files.
Okay, I thought it
You can
was
say sort of,
a Word document, and I was trying to get me
yeah,
very puzzled.
got yeah, my mistake. And then the
Okay,
TRS is the transaction replay server that reads events out of the doc and applies them into wherever the target is, or in this case, it'll execute the user exit
ah,
quick enough.
okay. All right, so it's a decoupled environment. So you've got something that's receiving the data from the nonstop, putting it into um, the, the flat files, and then a
Right,
separate process that's reading stuff out of those and doing something with them.
right.
Now, does it delete the stuff out of the doc files after it does it so that they don't grow?
Yeah, the TRS doesn't itself. There's actually a separate process that manages. It cleans up the old doc files, and that's how it's done. It's not done by that same process. There's a separate one that'll, once the TRS is done with it, it'll mark it as old, and then it'll keep
Okay.
X number of old sequences
Gotcha.
around.
Okay. I understand. All right. Or, well, I should say I think I understand. All right. So where do we want to go from here? So we have, let's see if I've got it started after I've rebooted a time or two.
Mm-hmm.
And I will show my screen.
Cool.
Okay, so my Shadowbase service is running.
Yep, good.
So then what, we want to run that Mon program and check things?
Yeah, exactly. SBMon. And yeah. Okay, it's running. So I know you did, I believe you did some events, at least one event on the source table successfully. Is that right?
Okay, yeah, I think I did.
Yeah. So what from SBMon, go ahead and
Oh, that's right. I deleted a whole bunch of, trying to clean things up to get things working.
Yeah, right.
And I got rid of a whole lot of stuff. So where to go? Oh, swell. Don't tell me I deleted too much. Oh, great. Okay. So I'm dead in the water. Should have tried this yesterday.
Well,
Hmm.
before we do that, let's go into SBMon and type log opcall. Let's just make sure it's running okay. And enter. And yeah, that's fine. It's pretty short. Okay, and now type log opcall again and just hit enter once. So here we have an option. You can do either trans or extpr. We want to do the second option, extpr. Yeah, and hit enter. And again. So this was okay. This is since May 31st. Actually, could you scroll up to the last log we did? Just want to see the timestamps on those messages. Okay, that's also May 31st. So looks like this has been up and running since the 31st, which is fine. So if everything's running okay, all right. So now let's try this. Type in all one word file stats space opcall, and this gives a overview, and then hit enter through the prompts. This gives an overview of the number of events that are in the opcall. So you can see there is that single insert. It looks like it was picked up successfully. I mean, we could just log into the database with SQL CMD, and that should, as long as that's still in the system, hopefully, that should allow us to continue to
SQL what?
CMD. I think so. Let me get the syntax for how to should be able to log in directly to the database.
So how in the world am I going to get SQL 2012 back on my machine? Great.
It looks like, yeah. I mean, it looks like the database is still there. I mean, the
Right.
call is still running. Yeah.
But I don't know. where it's going to go. He said he can't find. Well, that doesn't help at all. Shoot. Now let me see if I can find that. Who would have installed it? Probably one of the Visual Studio guys installed it. Great. Well, do we want to work on somebody else's machine then?
That's fine. Or I mean, we do have an event here. We can work on forwarding it and then getting it into the right kind of position for a user exit. If you want to do that for now. Either way though, it's up to you.
Well, yeah, I don't know. You tell me. You're the one that's training, so tell me what we need.
Yeah. Yeah, let's just keep going with this one. With this.
Okay.
Well, here, let's see if we can get in with SQL CMD. So go ahead and open a regular command prompt window. And just type in SQL CMD. See if that... Okay, I think it's working. So I guess break it, maybe? Control C or something. Okay. So now I'll give you the argument. So it's SQL CMD. And everything's separated by spaces. So it's -U. It might be uppercase U. I'm not sure. I'm not sure if that's case sensitive. But, so then the username, which is I think SA. I think that's what we're using.
Oh, right.
Connecting.
Right.
And then -P, capital P, and then the password. And then -S, and the server name, which is I guess laptop 3 / what was it? SQL SRV 2012, I think. SQL _ SRV _ 2012. And then -d, and then the database name, which was,
Test.
Okay, see if that. Can we look at the? Oh, I think it's the other slash. Laptop 3 /. I think you need to use the left arrow.
Oh, right.
Yeah, let's see if that works.
It's a different error.
Yeah, interesting.
Let's see. I wonder if.
SVR? Is that the problem? Did I say SRV instead?
Maybe, I don't know. Let's see.
Yeah, that might be it. There we go.
Okay.
Okay, so we can still do, events in here and stuff like that. If you want to, it's not as neat as using the management studio, but if you want to
Right.
stick with this, we can continue on the system.
I just wanted to capture
Oh yeah, sure.
what we're doing here. Okay.
All right. So, all right, we have an event in the op call doc. So now we can work on pushing that event over to the next step, the next downstream process.
Okay.
So we kind of have to hack things together because we have to simulate it coming from the nonstop.
Oh, okay.
So let's see. Next, we need to configure a doc process that will receive the events from this op call. So go ahead and type in add in this Bimon. Type in add space and then all caps doc, DOC. Yep.
That's it?
That's it. And then you want option 1, database of change. And you want the second option, SBO cons C. Yep. And then option 3. So we need an IP address. It has to connect with an IP address. Since it's coming from the local system, I think you can just use the 127.0.0.1. Should be fine. And then we need to give it a port to listen on. So some port that's available. We usually use like in the 30,000 range. That tends to be no problem as long as there's no, firewall rules. Yeah, perfect. And then just hit enter here. Enter here. And here. And here. And here. Let's see. Here type in the last option, SQLSBV1. I don't think it matters, but let's use the latest one. All right, and enter here. And then here just type in all caps open, just like above. And enter. All right, good. So now there's a doc that's been added. So if you type in list and hit enter, that'll list out all the objects that are configured. So you have your doc is, scroll up a bit to see your doc writer. Yeah, so there's your doc and then there's your op call. All right, so that's the doc, and we need to add a couple parameters, I think, with regards to this doc. So let's go ahead back to the data directory, the Shadowbase data directory.
Oh, I think I was there.
Yeah. And let's open up shadparm.ini. All right, so we have those two general parameters set, and that's it. So we need to add a couple more general parameters now. I'll type them in the chat window just so you can copy and paste.
Well, we have examples. Do we just cut and paste them?
I mean, you could, but it's
all right. It's fine.
Let's see if you can go find them. Yeah. All right. So there's one. And there's the other. So the
oops, that didn't go right. Interesting.
So that shad ignore mismatch, that's a very obsolete check to make sure that the object names are the same, but we really don't want them to be the same. Like, I mean,
okay.
It's mostly a thing for the nonstop, but it's very not used anymore. We just turn it we ignore that check. Shadow Monitor Server is a feature that will allow the doc writer to monitor the downstream TRS object, and it'll restart it if it sees it's failed. The problem is it has some holes in it, and on Windows it's much easier to just set up Windows services to
handle it.
Object.
Yeah. Okay.
Yeah, exactly. All right, that's it. So you can go ahead and save that, and we can go back to SBMon. And go ahead and start doc. Uppercase doc. Okay, give it a few seconds, then we'll check the log to make sure it should go into a waiting state. And we'll post a listen on that port. There we go, waiting session connected. Looks good. Okay, so now we have the doc that's waiting for incoming connection. So we need to now configure the piece that sends stuff from the op call to the doc. So since the op call is also, the op call has doc files, it stores the stuff that it gets from SQL Server into a doc, a database of change. So there is an object called a TFS, which is a transaction forward server that will forward events from one doc to another doc. So that's what we want to configure next, is the TFS. So go ahead and type add, all caps, TFS. And then option 6. This is the first option, SB open FW. And then this is local IP address. And this is the port that we specified last time, so 30,001. Yep, and enter, and then enter here. This is opcall, which is the name of the object we're forwarding. All right, and enter, and enter, enter. And this is that last option as well. And enter, and then all caps open again. All right, so now we can start TFS, and hopefully it will forward that event from the op call into the doc that we just configured. The TFS takes a little while to connect. So it's connected to the op call, and now it's initiating a client connection into the target doc writer. Looks good. Client session connected. Yeah, that looks all good. So now, to confirm, just type in that file stats command. Let's do it on the doc this time. And we should see that one event. And you can press enter through here. Yeah, there it is. Good. So you can see sequence number 1, the far left column. This by default, the sequence files will grow to be 1 gigabyte large. At that point, it's going to roll to the next sequence. It'll go to sequence 2, and then et cetera, all the way up through 999, then it'll wrap around again. You can configure how big you want each sequence to get before it will roll to the next one. And then that's kind of how you can control how much space is being used on the system by these doc files.
Okay.
So let's say if you bump it down to say 100 megabytes, if you want each doc sequence to be 100 megabytes, then that cleaner object I was talking about, you can tell that I want to keep 5 5 old doc sequences around at a time, no more than 5.
Oh,
So that
okay.
will ensure that you'll only have 500 megabytes of old doc data outstanding
Okay.
on the system at a time. The thing to keep in mind with that is when you are the doc writer, the doc writing with this guy that we just configured, and the TRS, which is the object that's reading events out of the doc and applying them downstream, they're asynchronous events, which means that if the TRS for some reason goes down or something, if it's lagging behind or anything like that, the doc will continue receiving events from the source, and it'll keep writing into doc files, even though the TRS is lagging behind, which means that there will be, kind of a surplus of events in the doc that have been written in the doc but not processed out of the TRS. So the one thing to keep in mind is with, when you're sizing your doc files, keep in mind that not only do you want to make sure there's enough room to maintain all the old stuff that you're going to keep on the system at any given time, but you want to make sure that there's enough room on the system that in the case of any kind of database outage or something like that, where the TRS isn't able to run and keep up, that there's enough space for the doc files to grow until the TRS is restored, and then it can dequeue all those events, if that makes sense.
Well, I mean, if it's going to create new ones, as long as there's physical space on the system, does it matter how big they are?
Exactly. Yeah, exactly. That's right. Just as far as allocating enough system space for doc files, that's the one thing to keep in mind.
Okay, yeah, just make sure you got enough real estate. Okay, got it.
Yeah, exactly. Yep. Okay. So we have our this is so at this point the doc here. This would be the doc TRS would be the only things you'd have on a Windows system when you actually, are replicating from the nonstop. The op call TFS, those are just kind of simulations of for now, since that's what we're working with. So next, what we want to do is we can configure a TRS, and we don't have any connection in the database or anything, but we can configure it, and well, I'll just show you. Go ahead and type in add TRS, and this is option 3. Now we have all these options here, all the different databases that we support, kind of out of the box. But what we want is that final option, which is the SBIG WRTC. IG, I guess, stands for ignore. It is basically a consumptive TRS. It's going to read events out of the doc, and it's going to just pitch them. It's just going to consume them. And the intention here is there's going to be a user exit bound in that's going to do something with these events, but it's not, the TRS isn't going to actually do any kind of downstream database.
Right.
It's not going to connect to the database or anything like that. That's, it'll leave it up to the user exit to do that. Okay, here you're going to type in doc. That's the name of the doc that we configured. Yep. And you can hit enter here, and here, and here, and here, and that stays the same. Yep, you can hit enter. And then you can just hit enter through here. This is similar to the op call as far as connecting to a database. We don't have a database to connect to, so you can enter through there. Yep. And then here again.
Don't we want to have the password?
It's not actually going to do any database connection. This is just going to.
Oh, that's right.
And then, so then you can just say yes to confirm that you want an empty password. Hit enter. And then just hit enter for now, but this is going to tell us, this will control the DLL name that we're going to use in our user.
Right, so you can do load DLL. Yeah, okay, gotcha.
Yeah, exactly. Okay. So now the TRS has started. Go ahead and start the TRS. It should have no problems because it's not trying to do any database connection. So it should start, and then it'll process the event, the one event, and then it'll stay running. It should. So still waiting. Still goes through its normal timer as far as delaying and stuff to connect, but doesn't really have to. All right, yeah, let's check again. Good. All right, and just do a status TRS. Okay, and just go ahead and do status space star. Cool. Good. So there's a very quick overview of all the objects and their running or not running state. That's good.
Now, are those configured as services?
No, we would need to configure Windows services for each object that you want to monitor. We can do that real quick if you want. Let's see. Yeah. In order to do that, we need to go back to a command prompt and get into the Shadowbase bin directory.
Well, probably want to be running it as an administrator just to be safe.
Yeah, I think you're right. That's a good point. Let's get the syntax here. Okay, here we go. All right, so from here, there's a little program near the top of your list called ntsbserve.exe, and that will configure a Windows service. It actually also configures that main Windows service that we used, but it'll also configure services for each object. So, so ntsbserve and then space dash install, and then space, and I guess let me just send you the next command to run. There we go. That's the final argument. Okay, looks like it was successful. Let's go ahead and check out the list of Windows services on the system. It should have shown up by now.
There was 2.
Yeah. Yeah, so if we make that big. Yeah, so Shadowbase is the executable name. Doc is, and that's the executable name for all Shadowbase objects. Doc is the object name itself, and then the one, it's always going to be 1 unless you happen to have more than one. You can have, like, say, a multi-ported doc writer that listens on multiple ports and applies all the same doc writer. It's actually 2 independent processes, but in this case, we'll use 1 for everything, basically. All right, so yeah, you can basically kind of do what you want with this. The one thing to keep in mind is that when you're using Windows services to monitor and maintain Shadowbase objects, the Windows service has to be the one to start the object. So right now, because the doc is started with SBMon, if we wanted to maintain it with the Windows service, we need to stop it with SBMon and then start the Windows service. And then it takes, a couple minutes. Yeah, you can do that now if you want to.
And we just did the doc, right?
Yeah, that's right. Yeah. And now we can start that service. All right. So this does take a couple minutes for it to finally get around to kicking it off.
Now, can we still do a status?
Yeah, sure.
Okay.
Right. Status should still be fine. So yeah, when when you have Windows services, you have to make sure the Windows service starts the object. Also, keep in mind if you need to stop an object for any reason, you need to first stop the service, and then you actually do need to go in and stop the object from SBMON. Stopping the service does not kill the Shadowbase process.
Do we need to look at the events to see if it had a problem?
I mean, it takes a couple minutes, but yeah, you can use the event viewer to see when it attempts to start or whatever. That should all be there.
So it says it started. So now if we do,
Yep.
still says it stopped.
Okay. Go ahead and do a log doc. Actually, can you go back to that message? The 3955. That's not. There's new events. You want to check? Okay, there we go. 4156. Want to check it again?
That looks better.
Yep. Okay, actually, go ahead and do log TFS. And enter. Yeah, you can enter through it. Oh, okay. So the TFS has the client connection into the dock. So because it was stopped, that will kill the TFS connection, and then it'll retry until it can reconnect. In this case, I think what happened is that since there's no activity going on, the TFS doesn't realize that its target server connection went down.
Uh-huh.
So the next time it'll try to do something, it'll notice that its old connection's gone, and it'll try to recycle it. But okay. So yeah, that's I guess. Do you want to do another Windows service, or do you want to move on next user exit step? Or I mean that you kind of have an idea of how to do the Windows services now. So I don't think we need to do another one unless you.
Let's go back to here.
Mm-hmm.
Now, how did it know it was called Doc 1?
It's called that doc in the middle, DOC. That's the name of the object, and then sequence number is 1 because there's only one. Not sequence. It's that's confusing.
Instance. It's an instance number if you had multiple ones. Now, how would you have multiple instances with the same name?
That's only if you have multi-ported stuff. You can have 2 different threads on the same doc object. When it asked us for a second port number, when we were configuring it, that's when you could specify more than one instance on a single object. But that's really only, that's a fairly rare configuration. It's only when people need a certain throughput and they need things to stay synchronized.
Okay. Now, would we still need to put in the -1 if we weren't going to have multiple?
Yeah, that there's always an instance associated with this, and
Okay.
in this case, you're just going to use 1 for everything. Also, I should point out that we're using very simple names, like our doc is named doc and our TRS is named TRS. Those names that we configured whenever we typed in add, like add doc or add TRS, those can be anything as long as it's less, 5 characters or less. Those are simply
I see.
that's the object name.
So when we did an add XXX, it then said what kind of things? Oh, uppercase.
Yeah, exactly. Oh, yeah, exactly.
And then you chose what kind of thing here. Okay.
Yeah.
All right. I was.
So go ahead and type.
I was puzzled because we did a doc and we did a TRS and it's like, wait a minute, they look the same. Okay, I gotcha. So
yeah. So go ahead and type exit, and then type list again and hit enter. So go ahead and hit enter again just to go to the bottom. Okay, so scroll up to back to the top of your output here. It groups these all by object type. So the first section are your doc servers, and there's only one. It's called doc. Then your transaction replay servers. There's one. It's called TRS. And then you have your open collector servers, which is opcall, and at the bottom should be TFS, I believe, or transaction servers.
We called it opcall, but it could have been anything.
Actually, in this case, yes, you can call it anything. If you do, though, there's an extra parameter you need to set because it's expecting opcall by default.
Okay.
But yeah, any of these you can call them anything. Yeah, and the transaction forward server is called TFS. Opcall is really kind of the only thing that it makes a difference what the name is.
Okay.
All these other ones you can call it, give them any name.
Okay.
It will just it matters the type of it. The type of object is what identifies it. So in this case, we just did very simple names. So like if you have more threads, if you eventually have more threads, you would have doc1, doc2 through docn or something. And then you would have associated TRS1 through N as well.
Now, how would you set up multiple threads in opcall?
You can't actually. You can only have one. You can only have one collector, one SQL Server source collector per
machine.
I think it's per instance, per server instance.
Okay, so when you said you could have multiple threads, then how do you specify multiple threads?
Not from a log, or not from the SQL Server source. You do it, in an environment from the nonstop, or from say Oracle source or something like that. You could have multiple threads.
I see. So each thread would be to a different kind of database, but you can only have one per database type.
No, it's really the only limitation there is SQL Server source. You can only have one collector. That's just how it works because it uses. I really don't know what exactly it's doing, but it's linked into the database, the running server process, and that running server can only know about a single collector.
Oh, okay. All right.
So but normally when you have nonstop out to Windows or anything like that, you can configure on the nonstop side to have multiple threads, where you have some files going down one thread and another files going down a second thread.
But those
break it up anyway.
But again, those threads, a thread. See, I'm thinking of threads from a Windows side.
Okay.
I have a process thinking of multiple threads. And how do you so opcall could be multi-threaded? Is that what you're talking about, or opcall is running?
No, thread. I'm referring to replication threads, I guess.
Okay.
How else could I? I guess.
No, that's fine as long as we understand that it's not the same thing.
Yeah.
So if I'm coming to a Windows machine from the nonstop and that's all I have, then I will have one thread, one replication thread, one nonstop to one Windows. Okay. Now, Go ahead.
Well, you can have multiple replication streams. Streams is a better word, I guess. You would have, you would have, let's say, three streams set up on the nonstop side, and then on the target Windows side, you have doc 1 through 3 and TRS 1 through 3, and each of those, pairs of doc TRSs would be a separate replication stream.
Okay. And how does it know where to go separately as they come in?
That's on the nonstop side. You configure, I want these files down this stream. I want these files down that stream. You determine which files you want to replicate down which replication streams.
On the Windows, how do I define which doc is associated with what stream?
IP address and port, basically. That's how it's tied back to the nonstop side.
But I thought the port it's talking to is opcall.
In this case, it is, because that's what our source is. But when the source is a nonstop, you're just going to have doc TRS pairs over here.
Okay, so I set up the doc on the Windows with a port that the nonstop knows, and that's how it knows where it's talking. There's no opcall involved.
Exactly, right.
Oh. Okay.
Opcall strictly because we have SQL Server as our source. That's our only option.
Okay, no, that's fine. I'm just trying to understand. So now that makes sense. So, and that's going to dump directly into the doc, and then we just have a TRS.
Right. So the opcall and TFS in this case are the opcall TFS are things that you won't actually have when you do this for real. That's just for now.
Okay. No, I just trying to understand it. Okay. All right. Does anyone else have questions at this stage?
No, I don't think so. We're following here, and what I'm going to do, Donald, is take the video after this and go through and try to do these steps on our instance as well after. But
right.
I think I'm okay.
Right, and you probably, since you don't have a nonstop, you'll be playing mostly on a pure Windows environment. But ultimately, we're going to be wanting to look, So now I've got the connection. Probably should have pulled up one of the diagrams.
Fortunately, it's much easier to configure Shadowbase on a nonstop as opposed to SQL Server source.
Okay.
It's much fewer steps involved, and we have scripts that'll write the Shadowbase configurations for you on the nonstop side. I mean, we'll still need to probably have a session to go over it, but it shouldn't give us any mysterious issues like we always seem to kind of get whenever we do SQL Server source installations.
So I think what we're going to want to do here, okay, I'm going to connect to PAP-A for a minute, so there may be a delay. Let me pause the recording for a minute. All right, so where did we want to go from here?
All right, I guess at this point we can talk about user exits if you want.
Yep.
So let me, I guess I'll send you a sample.
Okay, that'd be good. Yeah, one we can just start with, because.
Yeah.
Is it in C++, I assume, or is it a C# or?
It is C++. I think it's C. It might be either C or C++. I think it's. Either way, it's similar, but I think it's officially C++. All right, so let me pull up this file here.
So the way that it works is that there's a bunch of calls that are going to come into the DLL, and they have to be there. They may do nothing, but they have to be there. Is that correct?
The calls to the DLL?
Yeah, the user exit calls, we have to instantiate them in our DLL. Even if we don't want to use them, we just have to basically return back success because it's expecting them all to be there. All right.
Yeah, exactly. There are stubs basically for all of the APIs that are required.
Right.
And actually, let's look at that first. We can look at the C file. It's in the Shadowbase directory. Go up a level, and then into the user exit build folder, and then into there, and then into source. Yeah, you can open that up, sure. I think it'll ask you to convert it. I'm not sure. Yeah, that's fine. So the source files. Yeah, so that's our source files. You can open that up. All right, so this has all of these stubs in it. For all, if you look at all those APIs, those are the ones that it's expecting. So these are all stubbed out in this file, so you can scroll down through and see. Yeah, so here's the first one. User X init. It just returns. They're all voids, I believe, and they all just kind of return.
Right.
So this is the.
There's no way to report back there's a problem?
Yes. I mean, you log messages, you tell it to append. I mean, you don't control anything outside of these functions. Like if you want to, you don't say return error from one of these functions, and then you will tell it, like, if you get an error that you want it to, after you log your messages, if you want it to append or you want it to fail, then you specify that you're going to tell the object that you're going to fail after, once you return out of this call.
Well, how do you do that? I don't see.
Oh, there's function calls. There's a whole manual full of function calls.
Okay.
That you can use that are, Shadowbase specific, like getting values and
okay. All right.
And logging messages into the error log and stuff like that. All right, so let me send you. So this is basically your square one where you'd start from.
Right.
And let me get my my guy.
Well, apparently they were having issues because they were sometimes didn't know the EPS map these fields, so they either the character put in space or if it was a that was going up to the nonstop, or if it was a numeric, it was zero. And they worked all the sales ahead of time.
So this one's actually this sample I'm sending you. This one's good because it has a lot of it's doing a lot of work. Like it's actually this example. It's creating flat CSV files based on the incoming data. So it'll basically just dumps out the contents of the event into a flat file and moves on.
Right.
But
the event that you're sending has the actual data plus some kind of header that Shadowbase uses to indicate things about the data. Is that correct?
Without losing data.
Actually, in this case, there's not a whole lot of header information. That
don't we need to know whether it's an add, insert, or delete?
Yes, that is present. You're right. That's exactly right. You can tell what kind of event it is.
Yeah.
But as far as like when you have, sorry, hang on a second.
All right. When you have a user exit on the nonstop side, there is a lot more information about the audit trail event that generated it, and like the transaction. And you can actually read, you can get information about the source table itself as well if you want to. That is mostly unavailable on the target side in the Windows environment. All that metadata about the event does not get sent across, generally because the customers generally don't really want it, and it adds extra overhead to each message being sent. But so yeah, there's a certain level of metadata, like what kind of insert or what kind of event it is, but it's mostly just the kind of the column names, the values, and the lengths and stuff like that. All right, let me.
So if it's a SQL table and only certain columns are being updated, is that what comes in, or do we get a copy of the whole new record?
It will be whatever is sent from the nonstop. So on the nonstop, if the update, like if you can tell the files that you want each update to be compressed, which means only the rows that are being updated will be present in the update event. In that case, that's all that will be sent downstream to the Windows side.
But
otherwise,
is it
if you
all
don't
the columns of all the rows, or just the columns that got touched?
It'll only be the ones that are being changed.
Okay.
Otherwise, if if audit compress is turned off on the nonstop side, then Shadowbase on the nonstop side will receive every column, and it will actually send every column as well.
Okay. So it's controlled by the nonstop side. Okay.
Yeah, that's true. And actually, Shadowbase has an override where you can, even if the file is told to compress the audit, Shadowbase can actually, on the nonstop side, it can go back and fetch the other columns that are not present, and it can fill those in if needed.
Oh, okay. Because I would sort of imagine that if we're going to AWS, we want the whole row, not just the columns that got changed, so that we know.
Yeah. Okay.
Something. Not sure.
What is the source? Are they SQL MP tables on the source side on the nonstop?
Good question.
Okay. Yeah.
Yeah. I mean, it depends. I mean, Pape is just now converting, starting to do SQL, and they have escort and stuff like that. But I think GB. I don't know. I can't answer whether we've got.
Yeah.
Whether it's going to be just drive or whatever.
Okay. It shouldn't be a problem either way. It's just when it's nscribe as a source, you need to give it a dummy.
Should I not do that?
I mean, depending on how much it's changing, you may need to give it a dummy schema that it's going to use before it gets sent downstream to the Windows side, just to make sure that all the columns are named correctly and stuff like that. But all right, so that should be on its way to you. I just sent you the sample userx open.c file.
You sent it via email?
Yeah, let me just make sure.
Yeah.
I replied to the one that you sent. Okay, good.
Okay.
All right. So once you get past the initial block of comments here, the first chunk is a whole bunch of kind of supporting functions. So keep going down. And keep going, I guess. Some globals here. And so there's a structure. This is all kind of, everything here is user defined or, user written.
Okay.
So this is the, so byte swap. There was just some stuff needed for.
Oh, right, because you got to deal with the two big Indian, little Indian stuff and all of that.
Yeah.
Okay.
Exactly. So this has quite a bit of kind of complicated supporting stuff that's going on. I honestly don't know what really it's all doing, but this is all related to, file maintenance, like, opening files and writing to files and stuff like that. So if we get down past this, if we go down to the APIs that are all caps, like the ones that the Shadowbase APIs. So keep going down. Trace, open new file. Okay, here we go. So this is the first user init.
Okay, so the SB, the uppercase things are callbacks that we can use.
Right.
Right,
so all of those SB APIs are documented.
Right.
And they're in a manual. They're in a single manual, and it covers both nonstop and other servers calls. So some of the calls aren't available on say Windows, but
Shadowbase
programming manual.
This guy.
Yep. Yeah, and this.
No,
There's a table of contents, and it's all the calls start. Go down a little more.
Oh, here's the callbacks.
Right there under step. There you go. Yeah.
Those are all the callbacks. All right.
Yeah, and you see there's SB get functions. There's a bunch of SB get functions.
Oh, now I remember. Yeah. Okay, now it sounded familiar. Yeah.
Good. So let's go back to the code, and we can kind of just talk through what's going on here at a high level. So that SB get env, that is used it'll get an environment variable, or it can also read the shadparm file. So you can set custom parameters in the shadparm file if you want to, and then you can get them with SB get env.
Now in that shadparm file, which we were looking at, nowhere to go.
Yeah. It's your next tab over. Thank you.
Yeah, sorry, I keep forgetting it's in something else. So how does it just go under general? I notice it, or are there
It goes under general. Yeah, actually, we haven't had to do this yet, so we should probably explain it. Go back to the top. So let's see, what can we do? All right, let's do this. Add a couple lines above general. And then we can actually tell parameters to be applied to specific objects by putting them in their own sections. So right now there's a general section, so you can do, say, TRS. Yep, and then close it. So now anything under there will be applied only to the object called TRS.
And that's the name we gave it. The name we give it.
Exactly. Yeah, exactly. That's the name of the object, not the type or anything. So since the TRS is the one that runs the user exit, if you have any custom environment variables variables you want to set here, parameters, you can set them under that section, and then it'll pick them up.
Okay.
You can also use general if you want to. Either way is fine.
It'll look in both.
It will look in both, yeah, both in the specific and the general. I guess the only rule is that general needs to come at the bottom, because if there's a specific one that needs to override
right,
general,
yeah, you want to precedence the one above it.
Exactly. Yep.
Helps if I have my fingers on the right keys. Okay. And probably want to comment this out.
Yeah, sure. That's fine.
Okay, just as a placeholder. Okay.
Mm-hmm. All right. So that's userx init. So userx init gets called once, and these entry points here, userx init, the one below it, userx role, those are all explained in the manual as well. But
Right.
the userx init gets called once, a single time at startup. Userx role, you probably will need to use. We can skip over that one. Userx exception init. This is used if you want to be able to do like exception handling, like if an error occurs trying to apply an event into the target, then you can do exception stuff where it'll do some programming after it gets the error.
Oh, okay.
I don't think that'll actually come into play in your case because you're kind of dealing directly with the target, with the AWS. I think a lot of it, like you won't be able to use kind of the default TRS behavior where it's it's connecting to database and applying stuff. So that some of that might not be applicable to you.
Right.
All right, let's keep going down. UserX start. That is called. I think it's once for every. I forget if it's every unique kind of statement that gets replicated or something like that. But that's kind of another one-time thing. But it's called once per something. I forget that.
Well, it looks like if it's got an X, I'm guessing transaction. Does it? Does it know about a begin transaction, end transaction? Does that get replicated into Shadowbase? Do you know when those happen?
We know. I believe that the user exit. That's a good question. I need to remind myself whether it will actually trigger on begins or just commits. You kind of need to you tell it. You can tell it that you only want to trigger on, say, insert, update, deletes, or whether you also want to include the boundaries. But I forget offhand if begins are part of that as well. I know commits are. Commits are definitely.
And that's really probably all we care about. Is I don't really care what happened in between, but when you've committed it, all the updates that were within that boundary, I want to get all that was at that time. Okay. Yeah,
exactly. Right. Yeah, those are all part of it as well. The name there, UserX start, that's just UserX's. That's just our abbreviation for user.
Oh, I see. It's not USR X. It's user X.
Right.
User exit. Okay, got it. Never mind.
Yep.
Never mind. Okay.
All right, keep going. So so this is all the header for the UserX process function. So you can keep going down. This is where the meat of your code will live. This is what gets called every time an event occurs.
Okay.
So let's see if we take a look at some of the stuff. Line 477. That is a structure, process info, that's going to be defined, and that's all. The structure is defined by Shadowbase, but it's basically a structure that will contain stuff about this particular process.
And it's in one of the header files. Yeah, it's in one of the header files. Exactly. And then then you populate it with 479.
Yep. Okay. Exactly. So then we start using it right away, 480. If processinfo.eventID is an insert op, meaning if this is an insert, you're going to do this. And there's insert, update, delete. There's a bunch of them. They're all also mentioned in the header files. So this is where you can control it based on what kind of event it is that .eventID attribute of that structure. So in this case, if it is an insert, line 482, it is getting the column. It's getting the value of the column called header in the statement. In this case, this event it only contains two columns. One's called header. One's called record data.
I see. Okay. So it's your header, not the data.
Yeah, exactly. This is a column in the event called header, and so you give it the name, which is header there. isKey is a short that will return whether or not it's a key column. And then header size is the length of the value of the column.
Right.
And then header itself is the actual value. There are return codes that can mean
we probably don't really
things.
normally care what's in the header. Let's just make sure that we can get it.
I mean, in this case, this is a column called header. I honestly don't know what what header is on the in this event. I'm not sure what, but yeah, you would do get after column for call 1, or
I see. Okay. All right.
You give it the column name, and then it repeats it for the column called record data. So here's a question: do you have a high-level plan on how the user exit, what you want it to do with the statements that it's getting?
No, not yet, and that's sort of the thing. So Chris Cullen has played around a bit, inserting into some of the AWS database environments. So he perhaps would have more knowledge. But we have to look at the source. That's the question I've had to Phil is, the approach I take is, what do you want to do with it once you get it on AWS? And what do you need on AWS to be able to do what you want to do? And then how do I get that from the nonstop into AWS? And we haven't gotten far to answer those questions yet.
Yeah, fair enough. Sure. Okay. So in this case, these examples are showing you how to get column names in the event by name. Sorry, get column values. You can retrieve the column values into your code, and you can get it by name.
Now, these are assuming it's SQL, then I assume, if it's got a column. Or can it also be...
Actually,
go ahead.
Once it gets, even if it's nscribe on the source, it's going to be SQL on the Windows side.
So you have to provide a DDL for the record so that it can then apply a name to the fields?
Yes. That's exactly right.
Okay.
On the source side, if it's nscribe, you give it a DDL record name.
All right.
It has to be normalized, actually, completely. Just a single list of column or of record names, and then based on if anything special needs to happen with any of the columns, like if you need to only replicate a subset of the columns or anything like that, you can also give it a dummy record. Or you can give it a dummy MP table definition as well, and that kind of does more formatting on the statement before it gets sent down to the Windows side.
Okay.
But either way, once Windows gets it, it's in SQL format, no matter what the source is.
Oh, okay. Gotcha.
So let me just real quick find the column I'm looking for. I can show you in the manual. So that's SB get after column. The after just means, if it's an update statement, there's the before image and the after image. It'll get the after value.
Okay. Yeah. So if we went down to this only does
actually the only. Yeah. There's after and before columns. So you do after for inserts and updates, and generally you do before for deletes. They're actually on the Windows side. There is no before image available for updates. That's only on the nonstop side that it has access to the before image.
So if we were doing a delete, would we still get the after, or would we?
If it's a delete, you would want to get the before, actually.
Even though there isn't a before.
Well, sorry. For a delete, that's actually all there is. There's only a before.
Oh, okay.
Yeah. I actually think that you can probably call after on delete, and it'll just get the value anyway. I don't know if it's strict like that, but as a rule of thumb, you do before for delete.
Right. This is what the record was before I deleted it. Yeah, I got it.
Yeah, exactly. Yep. So those calls there show you how to get a column by name. So depending on if you need to do that, you can do that. Can we go to the manual, actually? The programming manual? And if you can, search for SB get after column index, all one word.
SB
get after column index. So this is similar. It will also get the after value of a column, but it does it by index number, like ordinally in the statement. So
sure.
you scroll down just a little bit, and it has an example.
Yeah, get the first, get the second, get the third. Sort of like
that great.
Well, just like when you're doing a reader in C# or something, where you're calling a reader and saying, give me the first, second, third instant. Yeah.
Yeah, right. So this will, you can kind of set up a loop if you want to, and just go from 1 through until you don't get any more, and that'll get every single column value.
But it will only get the volumes and not the names. Is that right?
Oh, it'll actually get the names too. In this case, if you scroll back up to the gray text, the gray box rather, you give it the index, and then it actually does return the column name. That second argument, it'll return.
Oh, okay.
Call.
That's what that is. So there's a column name, and there's the okay.
Yep, and then the value. Yeah.
Right.
So depending on what you want to do, you may end up using that. You want to just iterate through all the columns in the statement and just get them all.
Right. Now, does it specify? No, it doesn't. Does it warn you how big you need to make sure your call and val are, so you don't overwrite?
Right. I mean,
I don't see anything in there.
It doesn't. That might say something.
It doesn't ask it. It doesn't.
Yeah. Well, make sure it does say third. I think third bullet from the bottom. Yeah. Make sure the val argument is defined large enough to hold the maximum value that return.
Same thing with a column. Yeah. Exactly.
Yeah. Exactly. Yep.
So okay.
Yes. And to be quite honest, I'm sure you're going to find, if you study this, you'll find lots of typos or things that should be said that probably aren't.
That's all right.
But yeah, in this case, yeah, okay. The thing is that this call in particular is only available on the Windows side, on the other server side. On the nonstop, it's not. You can also do something similar to this. It's just, I think it takes kind of 2 calls to do it. You have to kind of read the source schema and get the column name and then get the value by name. But you can still do it kind of iteratively until you're until you're done. Okay, so on the Windows side, well, when you're dealing with SQL, whether it's on the Windows side or if it's on the nonstop and you have a SQL source table, you can't just get everything in the statement all at once. It's got to be, you have to get all the values by column name.
Okay. So you would have to iterate through to get them all.
Yeah, right. If you want to get all the stuff, all the data out of the statement, you would need to go by column name. If the source is nscribe, you can get the entire record because that is basically just a string of bytes. You can do that if the source is nscribe. And it's instead of SB get after column, it's SB get after record. So that's another API. Yeah. So this is only available in the nonstop, and it's only available if the source is nscribe. But if you scroll down a little more to the it returns a length and the value basically of the record. So that can be useful if you do want to, if the source is nscribe, if you want to just do everything in one fell swoop.
But that's only if there's a user exit on the nonstop. So by the time it gets to to Windows, that's gone.
Yeah, exactly. That's true. Definitely.
What would happen if you called it, I wonder, from your Windows program?
I don't think it's actually in the header on the Windows side. I think it's not defined on the Windows side. Good question.
Yep.
Okay. Okay, let's I guess can we let's look back at our the sample that I sent.
Just for grins, make sure that.
Sure.
Yeah. Okay. Make sure the search was doing what we wanted, so that it wasn't giving us nothing
right.
incorrectly.
Right.
Okay. Cool. Yeah. So it wouldn't even be.
If we go back to the notepad with the user exit file. I just want to see what else is here. If there's anything else.
No, there's nothing after I looked. So.
Well, let's look at Let's go scroll up a little bit in the middle of that. Yeah, let's look at SB log fatal. That API that probably has calls to the being able to log messages. Oh, sorry, that's my mistake. That's actually not a standard call. That's in that particular code.
Oh.
If we find it in there, yeah.
I'm not running it in here.
Here we go. Yeah, let's take a look at this. The thing here is that SB log event call. That's the thing that you can.
Oh, okay.
That's the one that you can look up. This is on the Windows side. It'll log a message into
EMS.
TRS error log.
Okay, TRS.
Yeah, on the Windows side. Yeah, and on the nonstop side, it will log it into EMS.
Okay.
Exactly. And there are some calls like there are some options here. I think I'll take a look at the call in the manual. That should have some. SB, yeah. So that first argument, critical event, that's purely EMS, whether it has the the flag or not.
Right.
And then you can give it an event number and that need operator flag. I think that's all just other EMS stuff.
Yeah.
And then you have the message itself, which I think the max is 32,000 or 3,200 bytes or something like that. So that's how you can log messages as you need to, both on nonstop or Windows side. You can use that same call.
Is tracing more detail kind of stuff, I see?
Yeah. It's a good question. I guess that's a nonstop. That's nonstop only. If you see that first right underneath where it's highlighted, it has.
Yeah.
You can see it's only available on the nonstop side. So you can enable the tracing option on the nonstop, and then if it's
I see. Yes, and this one said yes, no. Got it. Okay.
Right.
Okay.
Yeah. That SB set append call, that tells. If you just call that's just a single call, no arguments, no return code.
Yeah, you're not coming back.
Yeah, right. It'll actually run and it'll return, like it'll give you back, it'll get back to your user exit. But once you return from that, from that API, it'll tell the object to quit. Either it'll append on the nonstop, or it'll kill it on the Windows side.
Cool.
Yeah, let's see what else. Without logging, I can append. On the Windows side, I don't think this is true on the nonstop side. If you go to the bottom here, the bottom of this file, there's user X stop and user X exit. I think one is if it fails expectedly, like with a stop command, or one is if it gets an error and dies. You can put in some code to do before it fires that stuff.
Oh, I see. So you get notified, hey, we're heading south, and if you want to do something to clean up or whatever else, you better do it now because we're out of here.
Yep. Exactly.
Yeah.
Yep. And that's kind of the opposite of the user X init, which is the thing that gets called once at startup.
Right. Well, again, Yeah, init at the beginning and exit when when it's going out.
Exactly.
Yeah.
Yep.
Okay.
Yep. And then let's see. I mean, that's kind of most of what you would need. There's a lot of stuff. There's a lot of stuff about like you can do SB put instead of SB get, but you won't be using that because that's used like if the TRS is actually doing the events to the database directly. Since you're doing your own I/O, then you'll use your own stuff. But SB put is what you would use to kind of put new values for certain columns.
Oh, I
the
see.
opposite of SB get.
Oh, I see. So you could override potentially something.
Yeah.
Say.
Yep. Exactly.
Yeah. Okay.
Yeah. I trying to think if there's anything else user exit related that you would want to know about for now. Yeah, I guess what we recommend is when you have an idea of what you want the user exit to do, let us know and we could kind of get you on the right track.
Yeah, that sounds like a good idea. Yeah. So, like I said, those will be conversations with Phil and I think probably our initial target will be Gallagher Bassett, but they're the ones that are most. Well, actually, I think he said yesterday, the other day, that they're already doing some stuff directly to AWS. So not necessarily from Shadowbase, but just they already are familiar with it. So they may have some some recommendations. Okay.
Okay. If you want to, if we have time, we can try to compile a very simple user exit that does like it logs a message to the error log or something like that, just to go through the compile and how to specify the DLL.
I think I understand it pretty well.
Okay.
Yeah. Let's see. Where did we? That was when we were setting up the TRS, right?
Yeah.
When we specified the DLL.
Yeah. I can show you real quick. SVMon. You would stop at TRS and then you type edit TRS. Yeah, that's good. All caps. And then edit TRS. And it's just going to make sure it's not running because you don't want to edit it unless it's running. All right, and then just say yes to continue. All right, and then so this is exactly like your configure, but this time you can just press enter to leave everything as it was before. And so you just press enter through all your prompts. And it was at the bottom. So yeah, this is all the database stuff that you can leave as is. So right there.
Yeah.
That's where you give it the other.
Yeah. So we xxx.dll. Yep.
Yep. And
now, where does DLL need to reside?
Yeah, I'll show you now. Go ahead and hit enter just to finish that up. Go back to your Windows Explorer.
Oh no, we're in my graphic.
Yeah, your Shadowbase install location. So go back up to the main directory, and it's in bin. So there's the DLL now, and I think actually if you use the project, the Visual Studio project, it'll compile it. It gives it, I think it's called custom UE.dll or something like that, and it'll put it directly into here. And this is where it'll look if you don't fully qualify the file name. Otherwise, you can just give it a.
You could fully qualify it.
You could, give it the full path. There's also a shadparm parameter that can point to the library name. There we go.
I wonder where it's wherever outdoor is. Don't know. Yeah. Anyway, no problem.
Yeah. Oh,
we can move things around.
Yeah. Okay. I guess there's another parameter to set to tell the TRS that you do want to start like you want to use the user exit. We can deal with that later if you want. If you don't want to
say it again
now.
Is that here?
There's a parameter. No. Yes. It's here. I'll type it in. It goes in under the TRS section. That guy right there.
And it needs to be under TRS, not under general?
Yeah, I mean, you only want it to apply to the objects that are going to have a user exit enabled on it. So in this case, you wouldn't want to tell all the other objects. You wouldn't want to set that under general because then all the other objects would
look for a user exit.
Yeah, and they wouldn't find anything, but it would just kind of, I think might slow it down. It's going to like do some extra parsing of the statements and stuff like that.
Yeah, makes sense.
So yeah,
okay.
We'll just to give it to the TRS. Yeah, but I think in this once you have your DLL compiled and you specify that name in the TRS, it should be good to go at that point.
Cool. All right. Let me do some stuff here. Put that in our notes. Oops. Was in our notes. I think that's what it was.
Yeah.
Yeah. Okay. No, I'll figure somewhere else. Okay. Cool.
All right.
I think that's more than enough for us to get into deep doo-doo.
Yeah, go for it. Yeah, so certainly let us know if you start doing anything with user exits, have any questions or run into any trouble.
We shall. Yep, absolutely shall. John or Chris, anything?
Chris, can I just ask just a general high-level question, just to try to help understand how the user exits work a bit? If I just take a straight SQL Server scenario, so say SQL Server replicating to another SQL Server database, and let's say there's two tables in SQL Server, customer and address, and each table has 3 or 4 columns. And let's say there's an application that does an insert into both of those tables, as part of the insert. It inserts a record into the customer table and inserts a record into the address table.
Yeah.
The user exit that will fire, the processing exit, the one that fires all the time, I forget the exact name, but it was user exit process or something like that.
Yeah. Mm-hmm.
How many times would we come into that user exit process? Would we come in once for the customer table and then come in again for the address table? Or how would that work?
Yeah, exactly. Yep, exactly. It gets fired once for every every individual event that gets processed by Shadowbase. So in that case, you're right, it would fire once for each insert into each table. Depending on how you have it configured as well, it will fire for the commit. And I don't think the begin. I'm not entirely sure, but it'll get called for the commit event. And there's also I think there's also another kind of event called no more data. Like if the TRS has reached the end of the doc that it's reading, that'll call it a no more data event, and that'll also call user X process.
But the event ID will be different.
Yes, exactly. You control your behavior based on that event ID.
Now,
and that'll that'll tell you whether it's a.
So going back to John's question, so if I have, say, 3 tables on the nonstop, am I going to be having then 3 threads, 1 per table? Streams, I mean.
That depends on how it's configured. You can replicate all 3 tables down a single thread, in which case you would have, your user exit here. It would get called 3 times, once for each insert, and then it will get called for the commit.
But how would we know what the originating table was?
That's actually also part of the that's another call, SBGet. I should have mentioned that one. SBGet target table or something like that. There is another API. Yeah, let me find which one that is. Forgot about that one. SBGet. SBGet target, just by itself.
Chris, I've got a quick question for you. Yeah. If the userX process method is called for a commit, are we able to interrogate all of the statements that are part of that transaction and in that method, or are we responsible for sort of aggregating all of the userX process calls before that commit, and we kind of hold on to them until we see the commit get fired?
Yeah, understood. You're right. You would need to do your own kind of collection. The commit itself, you don't get access to the events that came before it by default, or that nothing comes through with that. It would be up to you to do whatever you want with the events that came before it, and then do something with the commit if you need to do that. Fortunately, the TRS will always process events in order, like there's no overlapping. So, once a commit happens, then any event comes after that is all part of the following commit. So you can do your own collection, like you're saying. That's certainly that would be the way to do that.
Question on the target. Go ahead, Joe.
Sorry. Do we see a begin statement so we can identify if a transaction is in process versus a non-transactional statement?
The TRS will only process committed events on the Windows side. So that way you can be sure if it's processing an event, it has already been committed upstream, and it's ready to be committed downstream as well. On the nonstop side, it's a little hairier because it'll apply events as it gets them out of the audit trail, even before they're resolved. So then afterwards, it'll get either a rollback event or it'll get the undo events to undo the work that was done if the source transaction was not committed.
But I guess my concern is that you can have SQL statements outside of a transaction, right? And so if you don't get the begin statement.
No, Shadowbase only deals with transaction.
Only with audited files.
Yeah, exactly. There you go. Audited.
And on
it's only audited.
Audited. If it's an audited table or file, you must have a transaction active before you can do an update. Any kind of add, update, or delete.
Okay, so everything happens in a transaction.
Yep.
Yep. Exactly.
Yeah, that we care about. Yeah. 2 questions, and one on the target. Is that the target in our case, on the nonstop? In other words, this was the originating file, or is this the destination where we're going to put it on the Windows side?
This is when you call it from the Windows side, it will return whatever the statement is that was sent to the Windows side. So you can, on the nonstop side, you give it your source table name, and then you can tell it to basically override whatever the table name is with your own value.
Okay.
Like it, because nonstop only have 8 characters in their table names, if you need to give it a different name on the target, you can override that. On the Windows side, when you call SB get target, it'll get that value. It's the value. It's basically the ultimate, like the actual target name.
Okay. All right.
What it'll get.
Okay, but it's not. In other words, if I'm going to be putting it in, if TRS is actually inserting it into a table on the Windows side, that's, I don't know what that name is, right? Not from the get target. Not from get target.
Actually, there's potentially, yes, it will, because there's a parameter on the nonstop side that you give it your source table, and then you give it the name of the target table on the target SQL server, or whatever the database is, the name of the table that you want to replicate into. So if you like, that's kind of a free form parameter. You can give it any value.
Okay.
And then if you give that value on the nonstop side, like the ultimate target table name that it's going to go into, then this call here to SB get target, if you do it from the Windows side, it will get the ultimate target that it's looking for.
Gotcha.
Yeah.
Okay.
If you could scroll down a little bit here, a little bit more. There's the C structure. So it returns the file name, and then type and subtype. Those are purely nonstop attributes.
Okay.
But this will give you the name of the table for the event that's currently being replicated. So
interesting. It's in nonstop format, and it's only 3 bytes as opposed to.
Oh yeah, that's the COBOL structure if you're coding it in COBOL, basically.
Yeah, but if you're on the Windows side, it could be something entirely different then.
You know what? I
don't think so.
I bet you. I would hope so. That that file name attribute on the Windows side is longer than 36.
Well, let's see.
That's a good question.
We just so happen to have that in our environment here.
Yep.
Oh, I hate you doing that to my thing.
Yeah, let's see that guy. Okay, max file len, which I would hope is
right, 256, probably.
Yeah, right.
Oh, 80. Take that back.
That's right. Yeah, that's generally I think that is the max that Shadowbase is able to replicate.
Okay.
That tends to be the max for most databases.
Right, and it's a database name, not a fully qualified path.
Yeah, exactly. Right. It's right. So you can use that to determine what the event is. That's if you have more than one table being replicated on a particular stream.
Right.
You would use that to tell what the table is.
Right.
If you do have, like you were saying, if you're replicating 3 tables, each down its own stream, on the nonstop side, if there's a transaction that is applied to all 3 tables, if you have 3 separate streams of Shadowbase, those will all get replicated down its own stream, each at its own separate transaction. So each TRS on the target side would apply those each as their own.
And doesn't know about the other 2, so you could end up with an inconsistency on if you had them as separate.
Right. Yeah, if you have any kind of dependencies on the tables, like if you have any whatever you call it, foreign keys or something like that,
Yeah.
You would either make sure that all those events are on the same thread so that they are all,
Right.
They're all synced up together, or if you need to have that multiple parallel streams to get the, more throughput, that is the situation where you would use multiple ports in a single dock, where you would have, multiple streams all going into the same dock set of files, and that way they would all be able to sync up and be applied to the target synchronously.
That's interesting. That leads to a question. So let's say that we've got, for just simplicity, two tables, and no, never mind. Answer my question. So I think, like I say, I think we're. Any other questions, John or Chris?
I don't know. Maybe I'm going to ask the question you were going to ask, Donald, because I'm still having a little trouble with the transaction piece. If I could just go back for a moment to the simple example, customer and address. So SQL Server to SQL Server, let's say. Let's say, so there's an application that does an insert, and it inserts, as part of the transaction, inserts one record into customer and one record into address. My user exit's going to fire twice the processing user exit, and I'm going to pick up the change on the customer table, and I'm going to pick up the change on the address table. If I wanted to do something with those two pieces of information combined, in other words, I wanted to take the customer and address, maybe my target, I want to put them into one denormalized record or something like that. Do I have that ability? Can I tie those two, since the user exit fires twice, once for customer, once for address, can I somehow tie those two together and being able to say that this change to the address table is part of the change that just happened to the customer table? Am I able to do that? So
what you would do,
part of the same transaction, something like that?
Yeah, I mean, we've done that kind of thing before. What you would want to do is, in this case, you're taking two inserts and making it into one, in this example. You would get the first insert, and then you would basically grab all the information from that insert that you need, store it, in memory, and then you would ignore it. You would tell the TRS to ignore this insert, and then it won't try to apply it or anything. Then the second insert would come through, and then you would, grab the stuff out of memory that you saved from the first insert, combine it with the second insert, and then you could, you could do a target override. Like you can change the name of the target table that you want it to apply to. So that way you could give it that kind of combined, table name. And then you would basically, make sure the statement's formatted correctly, give it the right columns and values, and then you could kind of let that flow through.
Right.
So how do I know?
That'd be you'd use a put then in that situation after you got it all put together.
You just put columns and all the.
How do I know? I was going to say, how do I know when the address, the second event fires for the address change? How do I know it's related to the customer, the one that the first of the prior event? What ties them together? This user exit is just firing. How do I know it's related? I guess.
Right. So I guess the question is, would they always come? Will they always come in the same transaction?
In the same order.
Even are those always going to be the only two events in the transaction? In which case you could just, the first one comes through, you set a flag saying, I got the first one, and then the second one comes through. It sees a flag that says it got the first one, then it, processes the second one, then resets the flag. So that way that a full pair has been processed.
They're always guaranteed to come in order, you're saying, I guess. It's all, whatever's coming in is part of the same transaction. They won't be intermittent, I guess, is the one.
Yeah, I mean, right. Shadowbase will apply the events. It'll process the events in the order that they occurred.
And it's by transaction level, okay.
Yeah, it's at transaction, so there's no overlap there's no overlapping. It'll always apply, in the order that it gets the commits for events. It's going to apply all the events in this transaction, and then the next commit occurs, and it applies all the events in that transaction. So, in that sense, you can be sure that the TRS will only apply events, for a given transaction at one time.
Okay, and then when the commit actually occurs, or the transaction is committed, that's when the commit actually. Is there something else that fires? Was that one of the other user exits? So I know that it's done. So I got the customer insert. I got the address insert. Something else comes in and says, okay, that transaction's done now.
Yeah, exactly. That will. It's configurable whether you want it to trigger the user exit or not. But yeah, exactly. If you once the commit occurs, the TRS will see that. The user exit will see that, and then in like you're saying, SQL to SQL. SQL Server to SQL Server environment, you can just kind of let the commit flow through, and it'll commit the transaction or the events that you already applied.
Right, but the commit will be the way I know I'm done. At least it knows I've gotten everything, and I can do my final processing, I guess, because I've got everything changed as part of that transaction. Okay, I think I got that. That's good. Thank you. It's just trying to understand that a little bit. Okay.
Yeah, sure thing.
So, Donald, if you could please send me that video, the recording here. Just I know Phil did it by you have an email capability, right, where you email these large files.
Well, I'll send it through BDS, but I have to first convert it. I have to.
Yeah, of course.
A while. Yeah, it goes through some kind of conversion.
Yes, and I don't know in the sample user exit if you could send it as well, the one we're looking at right now, and. I don't have the Shadowbase programming manual. I'm not sure how to get to that. Would it be possible for you to show me how to get that online or email me that as well?
Yeah, I can. Let's see, where was my list?
I have a link to. We actually keep all our manuals on the HPE website. I can send a link to for that.
Yeah, because you can see there's a whole pot full of them here.
Right, right. So it'd be great to get those. Yeah, if I could get that link, Chris, then that'd be great. And instead of the sample user exit and the video, the recording, of today's session. And I'm going to try the same thing in our environment tonight and this week. I'll try to get through it this week.
All right. Well, I think we're done then.
Yeah. Thank you very much, guys. Thanks, Chris, for going through that. And
next time. All righty.
Right.
Bye-bye.
Thank you. Bye.
Thanks, guys. Take care. Bye.